The video platform launched, and it went well. No outage, no incident, latency inside target. The team took the afternoon off. Then the invoice arrived at the end of the month, and it was several times what anyone had modeled. Nothing was broken, and nothing needed fixing, which is the uncomfortable part. Because a system that gets more expensive, the better it does, is not a performance problem you can profile your way out of. So let's design video delivery around the thing that actually dominates it. Not compute, not storage, but the bytes leaving your network. Start with the simplest thing that works, because plenty of products ship it. Put the video file in object storage and hand out the link. It plays, it is durable, and it took an afternoon. The cost model underneath is the issue. Storage is charged for holding bytes, which is cheap and roughly flat. Egress is charged for bytes leaving, which is not flat at all, because it scales precisely with how many people watch and how long they watch for. One popular video pulled directly from origin by every viewer means you are paying to send the same file over and over. And because it never fails, nobody notices. The system will happily keep doing this at any scale you throw at it, converting popularity into cost at a fixed rate. And the only signal you get is a number on a bill 4 weeks later. Before fixing delivery, the file itself has to change, because handing everyone the same high-quality file is both expensive and bad. A viewer on a weak connection cannot sustain it, so they get a spinner while you pay to send bytes they never see. Adaptive bitrate replaces the single file with a ladder of renditions at different qualities, each cut into short segments, plus a manifest listing them. The player picks a rendition per segment based on the bandwidth it is currently getting, and steps down instead of stalling. What matters here is the shape of the two costs. Encoding that ladder is compute you pay once per video, no matter how many people watch. Delivery is paid per viewer, every time. So the encoding side can afford to be thorough, and the trap is building a ladder with far more rungs than the audience needs. Every extra rendition splits your traffic into smaller pieces, which matters enormously for the next part. A content delivery network is usually sold as a latency improvement, and it is one, but that is not the main reason to run video through it. Put an edge cache in front of your origin, and the first request for a segment pulls it through and stores it. Every request after that is served from the edge, and your origin sends nothing. The number that matters is the offload ratio, the share of bytes served from cache rather than fetched from origin. At a high ratio, you pay origin egress once per segment per edge location and cheaper delivery for everything else. At a low ratio, you are paying twice for every byte, once out of origin and once out of the edge, and the CDN has made things worse. So the design question is not whether to use a CDN. It is what fraction of your bytes will actually hit warm cache, and that is decided by choices you make elsewhere. 3 decisions quietly destroy the offload ratio, and all of them are made for good reasons. The first is authentication. Protecting content with signed URLs is correct, but if the signature is a per-user query string that forms part of the cache key, then every viewer requests a technically unique URL, and the edge caches a separate copy for each one. Your hit rate collapses towards 0, while the dashboard shows the CDN working perfectly. Sign in a way that keeps the cached object shared, and configure the cache key to ignore the parts that vary per user. The second is the ladder. 10 renditions where 4 would do splits the same audience 10 ways, so each variant gets fewer requests, and more of them arrive cold. The third is segment length. Short segments seek and adapt beautifully and multiply the number of objects. Longer ones cache better and make the player clumsier. There is no universally right answer, only a trade you should make on purpose. The general lesson is that some architectures convert success directly into cost, and you only find out at the end of the month unless you designed for it deliberately. The Architectural Economics series treats the bill as an output of the architecture rather than a finance problem. Idle capacity, egress, storage tiers, and the decisions that set them. That is where to go next.